Electrolysis. Electrolysis is defined as a chemical change caused by the passing of a current through a compound that is molten or in solution. So here are a few other definitions that you'll need to know. The term electrolyte is the term which defines the substance undergoing electrolysis. The electrode is defined as a conductor through which the current enters or leaves. An electrolyte. This is usually carbon, graphite, which is cheap, or an inert metal such as platinum. The anode is the positive electrode, and the cathode is the negative electrode. Easy to use the abbreviation positive anode, negative cathode. So conduction by metals and by carbon. In metals, the electricity is simply a flow of electrons. Okay, all metals and graphite have these free electrons that are delocalized within their structure. This is because of the bonding present. Okay, the flow of these electrons through the substance causes no chemical change. The chemical change only occurs when it gets to the electrolyte. Okay, so the battery in the circuit . So the battery in the circuit simply pushes electrons through the carbon or the metal that's been used as an electrode. And then when they get to the electrolyte, a chemical change can occur. So a few words about electrolytes. They all contain ions. And in a solid electrolyte, the ions are not free to move. This means that nothing will happen if we try to use electrolysis on a solid electrolyte. However, if we use a molten or electrolyte or a substance in solution, then we can get electrolysis occurs. So it must be molten or in solution. So let's have a look at how we would do electrolysis of molten compounds. So start off here with, say, a beaker, and we have in it a source of heat underneath. Two carbon rods. You can draw this much neater than I can. And here we have an external circuit. Here's a bulb. And then we have our battery. This is the positive terminal, this is the negative terminal. So that will correspond to positive and negative for our electrodes. In our solution, we have got some lead bromide, which is Pb2 plus ion and 2Br minus ion. Okay, so that's our experimental setup. We'll just label the parts: bulb, battery, anode, cathode, and the electrolyte. Okay, so when the lead bromide is solid, nothing happens. Okay, so then if we have it melted, we get a few things happening. The first thing will be the bulb lights. The second one will be you get bubbles forming at the anode. And the third one, you have a metallic solid deposited on the cathode. If we were to remove the heat and it solidified again, then we'd go back to nothing happening. So let's explain what is happening here. So the battery pumps electrons to the cathode. This causes a build-up of negative charge, a build-up of electrons. Okay, so that cathode is electron rich now. This attracts the Pb2 plus ions. When they get there, they pick up 2 electrons. The lead 2 plus ions are reduced to lead metal, which is this is deposited on the cathode or falls to the bottom. Okay, so what happens then at the electrode is it leaves some space where those electrons have been, and that can be filled with new electrons that are pushed by the battery. So space is left on the cathode for more electrons, so the battery pushes new electrons along the wire and current flows. We have an equation for this. Lead 2 plus 2 electrons goes to give lead. Okay, just remember the acronym oil rig. Oxidation is loss of electrons, reduction is gain. So now we can deal with what's happening at the anode. The Br minus ions are attracted to the anode. Here they give up their extra electron. And they pair up to give bromine, and because it's warm, that's going up as a gas. The equation for this is Br minus giving Br2 plus electrons. We need to balance 2 Br minuses and 2 electrons. That's the most correct way of writing that, although you can show subtraction of electrons if you wish. Okay, so again, this is oxidized. Br minus is oxidized.